The question is, fetch and add of x comma I is an atomic read modify write instruction that reads the value at x, increments it by I and returns the old value of x. It is used in the pseudocode shown below to implement a busy wait lock. L is initialized to 0. 0 corresponds to lock being available and any non-zero value corresponds to lock not being available. So the pseudocode is acquire lock of L while fetch and add of L comma 1, L is equal to 1, release lock of L, L is equal to 0. So this implementation, option A, fails as L can overflow, option B, fails as L can take non-zero value when the lock is actually available, option C, works correctly but starves some processes, option D, works correctly without starvation. So if you take the given pseudocode and let's say take two concurrent processes, say P1 and P2 or P and Q. Let's say the first process P1 enters acquire lock of L. It goes in, L is initialized to 0. So it will increment it by 1. It will come out of that and then it will release lock and L equal to 0 if that is the only process that is happening. Assume a case where there is another process which after the first process P1 executes lines 1, 2 and 3, P2 comes in and executes lines 1 and 2. Then before the process P2 can do anything, P1 sets L is equal to 0 and then P1 comes here and sets L equal to 1. P2 comes here and sets L equal to 1. Now what happens is that P1 has completed this and gone. P2 has come in and set L is equal to 1, whereas there is no other process to set L is equal to 0. So to understand, this acquire lock happens only when another process releases a lock. So here P1 finished its job and should release its lock and P2 will come out of this acquire lock only then. So what happened in our case is that P2 came here and before it started busy waiting, P1 went and set L is equal to 0 and then P2 came and set L is equal to 1 here. So now since L is equal to 1, this will be true. So P2 will keep looping in this while loop and P1 already executed this and went off. So no one is there to release the lock now. So what happens is that P2 will keep looping here. So that is exactly what it is said in option B. It fails as L can take a non-zero value even when the lock is actually available. Here P1 released the lock but it just happened in a wrong timing. So the lock is free but the value of L is non-zero. So option B is the right answer.